Good morning, everybody. The process that I'll follow is I've got a presentation that that shows what the document is all about, or the key components of what the guideline is all about. And then, as was earlier alluded to by Dickie or by Tlangabeza, that we even brought our own rock drill. The rock drill is not here because that we believe is the only source of noise. It's obviously the piece of equipment that affects most of our employees underground, but it's here because it's so easy to transport and to bring here rather than something bigger that makes noise. Now, we can't get it to make a noise because they don't have enough compressed there, but we'll attempt to show you as practical as possible. So my aim is to take you through the presentation, and whilst I take you through the presentation, because I've got to hold these two things, we're also going to try to show you how to do the measurements or what it should look like. So just to start off with, the purpose or the contents of the presentation is the purpose of the guideline, measurement criteria, instrument settings, calibration, general procedures, measurement procedures, reporting. And then number 8 is, and again, we're focusing on the rock drills for the reason I mentioned earlier, that there are so many people affected underground by rock drills. The single piece of equipment that affects most of our employees underground in terms of noise. And we'll show from the reporting and from your measurements, what are the typical things that you should look for. Now, most of you may know much better than me what these things are. Some of you may have not seen it before, and we thought, as this is a day of learning, let's share some of this with you as we go along. Then we will have an interesting part in the document which calls for new equipment requirements, a rule of thumb that we believe that would help us on the mines to better accept or not accept new pieces of equipment. So the purpose of the guideline is the procedures aimed at providing a uniform method of measuring noise levels under realistic operating conditions. And Anton, when I'm finished with this presentation, Anton will be sharing I think the crux of the matter, which alludes to what Brian is trying to get at, is how to report this in a uniform manner. The work was informed by the guideline for the compilation of a mandatory code of practice for occupational health program in noise, which is what our COPs, for want of a better term, are conformed to. The guidance note for the monitoring of compliance with the Mine Health and Safety Council milestones for occupational noise issued by the DMR, and that document was issued around 2006. And then obviously input from senior industry ventilation and occupational hygiene practitioners. The names were mentioned to you a bit earlier today at the introduction to the session. Please keep in mind that this document is not designed to teach anybody anything. The document assumes that it is developed for people who, by virtue of their training, knowledge, and experience, have been found competent to do noise measurements. Now, the people in this room are obviously those competent persons that we're referring to. So there might be things that you thought that would be good in this document, but the document is more a guideline to get a uniform approach out there. So it's not how we measure noise or what the criteria is, etc. It's more about leveling the playing fields, for want of a better term. All right, so what is the measurement criteria? The guideline stipulates the parameter for quantifying noise emissions as equivalent continuous A-weighted sound pressure levels, which for a normal 8-hour work becomes the equivalent noise level for 8 hours. Should be measured directly with an integrating sound level meter that meets the accuracy requirements of at least a class 2. And that is from the original. If you look at the guideline, the guideline for the compilation of the Code of Practice, Annexure 2, as well as the guidelines that have been sent out by the DMR in 2006, it requires the Type 2 integrating instrument. The measurement criteria according to SANS is the criterion level must be 85 decibels, the threshold limit is 80, and the energy exchange rate, or the doubling, of 3 decibels. Although the instrument supplier normally sets these measurement criteria prior to delivery, the user must confirm the criteria. And we are not boasting, I brought it in, and you'll see a picture of a particular instrument. We are not advocating any particular instrument. What we can say is in the industry, and when you engage with the suppliers, the equipment is becoming more and more clever, for want of a better term. So there's very little you as the user or the measurer need to do. The instrument almost, if you set it up properly, can give you all the answers. So the instrument setting, the following instrument setting should be used. The A weighting must be on. The time weighting must be fast or impulse. If the noise is impulsive, the sound level meter has the facility built in. It must be fast or impulse if that facility is built in. If the sound level meter does not provide impulse integration, increase the measured LEQ by 5 dBA for moderate impulsive noise, example, the pneumatic rock drill, and 12 decibels if it's a compressed air driven charging up of blast holes, overblowing where you've got the significant noise, as well as the hammer blows. The frequency filter must be out, and the operating mode must be for integrating or averaging. So calibration. The following general procedures must be allowed. Confirm the sound level meter's acoustic sensitivity with the sound calibrated immediately before and after each series of measurements. Now, that brought some discussion in the team. Do we calibrate before the shift and after the shift, or do we calibrate before and after each measurement? And you'll see there for practical reasons, and because in the environment we operate, we said that we calibrate before the shift and after the shift. However, what is extremely important is if those checks do not coincide within 1 dBA, those results must be discarded. The bottom line is if you take these instruments, I mean, we have a lot of damages in cages because of people pushing, etc. The instrument must go underground in a protective case or a protective device that will protect the microphone from bumps, etc., that may affect that 1 decibel when you calibrate the instrument. And I've got a basic calibrator here. The instrument has a fixed calibrator, and if you take off the windshock, you insert, and the calibration in most instruments almost happens automatically, and you can log that particular calibration. Okay, so the general procedure for each workplace or area, select at least 3 microphone positions. And the important thing here is that when you measure a rock drill, and you'll see there 1.2 meters from walls or sound reflecting surfaces, the operator obviously is behind the machine. And the operator is almost at one hand, arm's length away from the instrument. So the operator is most exposed here. But you can take measurements at 1 meter from on the left and right of the instrument of the particular device, depends on what type of equipment it is, and those measurements are then logged accordingly. Typically, and it depends on the environment underground, and what Mornay said earlier is very, very true, that you can put all these nice things together, but if you're going into confined space, if you go into a 70 centimeter stope, the picture changes significantly. So the microphone positions should be for standing persons 1.5 meters above the floor, seated persons 0.9 meters above the seat, and at fixed workstations, and this is not necessarily a fixed workstation, but the piece of equipment cannot be operated unless the user has his hand at arm's length from the piece of equipment. And then obviously specific noise sources 1 meter from the source, as I indicated on the left and the right of this particular piece of equipment. And then where practical, some pieces of equipment are installed at a point where it has to be close to a reflecting surface, but where possible, 1.2 meters away from such reflective surface. The procedure, measure the LEQ for a representative time at each selected microphone position. And for steady noise, when it's not something that, like for a rock drill where there's a cycle, and I'll get to that just now, but for steady noise, 1 minute is adequate. And the most important part that I think one of the previous speakers also alluded to is the cyclical equipment. Where the noise varies or is cyclical, the measurement time should be sufficient to capture variations in the noise level and include a reasonable number of work task cycles to ensure representative results. It's very, very important. To go to a rock drill and to stand there for 1 minute, you can catch it at the wrong time. Collaring is one of the biggest contributors to the noise. If you miss that procedure, you're going to have the wrong readings. You're going to implement programs to try to eliminate high levels of noise where it was measured incorrectly. The measurement for the variation of cyclical noise will then be recorded as the representative noise level for the individual piece of equipment. Is there noise? Is there sound on this system? Klangabeza? All right, so let me, thanks to my colleague Anton, I'm going to now show you briefly, and if there's need be, we'll demonstrate more. And the piece of equipment is here so that we can ask questions around in a particular piece of equipment if the need arises. But what we'll show now is typically what we mean by the cyclical noise. Now again, I am certainly preaching to the converted, but it does make sense to sometimes see it again. All right, so before we go to the infamous clip with the noise, let me just raise the practical component here. The aim of the guideline is to get a noise source, a measured noise source, as I said in the beginning, to make sure that what we measure is uniform across the industry, and for that matter, for an underground environment. So, how we report it, Anton will go through that just now, and the detail to get us even better fine-tuned. But when we get into an underground environment, let's say, for example, we get into an underground stope. Now, it depends on, there are many factors that influence, such as compressed airs, the stoping width, etc. But if you go into a stope underground and you find a rock drill, there might be 3 rock drills drilling, and there might be a fan and other pieces of equipment that contribute to that noise level. The aim is to get this piece of equipment separate from the rest. Although we will measure the background noise, the aim is, as far as practicable, to get this piece of equipment separate from the rest. So, for example, you would go and switch off everything at the back, measure there are some things that you obviously cannot switch off. So that will form part of your background noise. Then you measure that piece of equipment. Now, the question is, do I measure all the machines in that particular environment? Not necessarily. You measure a piece of equipment if you're concerned, and I'll show you some of the examples why you should be concerned if you take certain noise levels. If you are concerned about the noise levels you've taken, you pick another piece of equipment. Yes, it seems and it sounds as if it's unduly onerous, but that is the best way to get a proper reading. Whether you have high stoping width or low stoping width, when you go into those environments and you will measure a machine in a high stoping width, and you will measure a machine in a low stoping width. You'll find a machine drilling closer than 1.2 meters from a reflective surface. You'll pick the other machine. The thing is, the bottom line is to find a piece of equipment that is separate, that has very little effect from background noise, that we can identify that particular noise level on that piece of equipment. Are there any questions as far as that is concerned? It does sound unduly onerous, it does, because you've got to take 3 measurements, etc. And in development ends, obviously, when you have more confined spaces where you have, in big, large development ends where you have 4 or 5 machines drilling in an end, you obviously have to switch off the other pieces of equipment in order to measure on that particular rock drill. And I'm referring to a rock drill here, as I mentioned earlier. Okay. So, what do we mean by measuring the cycle? The cycle means, in essence, the following. You have the start of the rock drill, collaring, drilling, withdrawing the machine from the drilled hole, and then stopping the rock drill again. That is a cycle. So every measurement at a rock drill should consist of starting, collaring the hole, which is one of the major contributors to the noise, drilling the actual hole, withdrawing the machine from the hole, and stopping the rock drill after that particular cycle. That is a cycle for a rock drill, or any piece of equipment that has a cyclical method of operating. Are there any questions regarding this particular one? And obviously for fixed noise sources, it is a 1 meter at those heights and etc. as we saw in the earlier slides, and that's how you measure because it's a fixed noise level. Yes, Joseph.
I don't understand that. Are you saying the cycle is from the start of the drill hole up to the end of the hole?
Yes, sir. That is the cycle of a rock drill. Because if you only measure the collaring, your noise level is going to be too high. If you measure the drill steel halfway into the machine, or into the hole, that is going to have a lower noise level than when you're collaring, etc. So the equivalent noise over that period is the cycle. I'm getting some very strange stares here. That's how we measure noise at rock drills. Am I right? Yes, Adolf?
If during the cycle you've got the stop, start, stop, starts, is it going to affect, your measurement? In other words, you collar in, he stops. He drills again, he goes in, he stops. Those kind of stops, how do they affect your measurement?
Look, it is not a normal operation. I don't think, and help me if I'm wrong here, but they don't normally stop, start as they drill a hole. So that would be, if you add them together, I guess it would amount to the similar reading. My suggestion is that you do a measurement full cycle, as the operator would normally operate that piece of equipment. That is the best way to do it, because that is that equipment noise for that piece of equipment. Remember, when you take that measurements, you now have to go to your engineer and say to your engineer, this piece of equipment measured at that cycle is giving me more than 107 decibels for them to address it. Then you can go and start doing and see, well, what is the major contributor? For example, the collaring. How do you mask or how do you muffle the collaring, etc.? And then when you do the full cycle, your noise level should be significantly lower if you address that properly.
So from the floor, anybody else, how do you measure your rock roll? Any other method?
Your method might be a better method.
Vicky, I think we should not presume that everybody does it this way. I think most probably don't. Okay? So what we are trying to do is to come up, the method is to come up with a practical way to measure equipment noise, practical, okay, that is uniform to all of us, that we can all agree on the scientific principles of how we decided to measure that noise. Ultimately, that noise comes down. Okay, so if you are doing it differently, so if you are doing only a spot measurement at equipment, at a drill, remember some equipment need a spot measurement static. It doesn't change, it's not a cyclical noise. Okay, then you take a 1 minute spot. But if you're doing spot measurements at cyclical work, like rock drills, you're going to have to change. If we all agree that this is the way that it needs to be done. So that when we speak noise, we all talk of the same issue. Okay. So, what am I trying to say? If you are not doing it this way, and you do believe that this is not the right way to do it, then we should have the discussion, or you should air your view now, at least we know. If we are saying, guys, we might not all be doing it this way, but we do believe, as professionals in this room, that that is probably the right way to do it. Okay. We shouldn't have this debate in 2 years' time again. Because many times we make decisions and we debate those decisions over and over and over again.
I think, Monet, what you say is true. I think, just to add something on the side here, when we submit the results that Anton is going to sort of take us how to do this, when we submit those results to industry or to the chamber from where it goes to the CEO committee for zero harm, which includes noise, dust, and all those, and that's the only time I'm going to mention the word dust. But where all of this is going to be addressed, remember, the CEOs have committed themselves to get the industry to zero harm. That means lower noise, lower dust, zero fatalities, zero injuries, All of that is what they have in, and all this information needs to inform them on how, on the way forward. If we submit these results, and one result is because of a fixed noise or a single noise measurement for 1 minute next to a rock drill, and the other is for a cycle, you can obviously understand that the information that goes there is going to be skewed, and the plans that we put in place might not be successful in getting us to zero harm. That is the critical part. But if there's anybody in this room, and this is why this is a day of learning, we want to learn not only from what these guys, my colleagues, helped me doing in this document, but also to learn from the people around the table who at this stage go underground far more often than I do, and some of my colleagues around that table. If you really believe that this is not the right way, come up, tell us so that we can take that discussion further and develop our strategies even, or the measurement tools even better. Is there anybody that believes? Okay, yes, one, thank you.
There is a SANS standard, but it's not for underground mines and stuff. But it say on the 6 measurements, half a meter up, down, left, right. What about that portion? Did we look at that?
The SANS standard. This document is based on the requirements from SANS.
But that one said half a meter each side, direction.
Well, I'm not.
Yeah, maybe I can help. So, you can't include the sand standard in the ground because the scoping environment is totally different. And the sand standard, helping, James will help on your opval.
I'll stop you immediately.
Is mostly on the free field measurement. Okay?
Yes.
So if I go and I've got a lekker open space and I want to be very scientific about it, I can go use the sand standard and say this piece of equipment on its own, free field gives me this one. Now, there's a big difference between a free field measurement and a workplace measurement because of cumulative noise, background noise, reverberation, size of excavation. And I can go on and on and on and on. So what this document tries to do is take the principles of the sand standard, okay, and apply them to an underground working environment. So it will never be exactly the sand standard, but it tries to make it practicable underground, how to do it best. And if we have to be very scientific about it, okay, there's a lot of holes in what we do because every underground environment has got some unique nuances. But this is to get as close as possible to a practicable, user-friendly, and all understand standard, based off the same principles.
I think just to add on to that, thanks, Monday. To add on to that is, if you look at the brochures, and I'm getting to that a bit later, but if you look at the brochures delivered by the majority of manufacturers, it is a noise level that is measured in a free field. It is not a noise level that is measured underground. And if I, Joe Soap, want to come to you and sell something to you, I come to the mine and say, here's the noise level. And we have to base all our decisions, whether we meet the milestone or not, on that piece of pamphlet that person gives you. We know that the environment, like Monet says, there are ASGs, advanced strike gullies, that are very small in dimension. We've got stoping widths of 70 centimeters. We've got vast open areas. So it is just the various areas to monitor are just so diverse that, we need to find something that gives us, at least as an industry, one common noise level that we can act on to get to zero harm. Okay, any more questions on this issue? But maybe I just need to say that I thought about it. What we've got, the Annexure 2 of the guideline for the compilation of a code of practice for noise, the DMR guideline that was issued in 2006, they were all based on SANS 10083. That's where that was the start from where we work. And we obviously have to adapt for the underground environment. Any other comments on this issue in particular?
I understand the compressed air drops. the people who's using hydropower, there's a little bit of a difference because the machine is much less noise. The most of the noise is at the front where the colouring is.
Yes.
So with that, then you'll not really get the right reading of the noise because the colouring, that's where the reading comes from. So in some of the instances, you have to really look at the portion where the noise comes from to get that 1 meter.
That would be part of your investigation. That would be part of your investigation to come to a point where you can eliminate that portion that adds to your noise level. But ultimately, even if that piece of equipment is used to drill a hole, the aim is to have it measured in that cycle, so your level will be much lower, and you can go even lower if you address the collaring at the face. Any more questions on this issue? Some people will say, so you're convinced this is the way to do it. Okay. Let's then move on. So when you report, there are some factors, and it was alluded to by somebody just now, there are some factors to be considered. We in the document advise on the following. Again, this is just for uniformity. Your specific mine or your organization might require other things. The name and description, the type of ventilation, the velocity, the background noise, as I mentioned earlier, the excavation area, temperature, because excavation area is important because they vary from mine to mine and mining method to mining method. Temperature, compressed air, pressure, it's significant. We had a short meeting the other day where we invited some of our colleagues to the mine to look at the practical considerations in the rock drill shop. And what I picked up, and I think it's an industry norm, that very few people, when you take noise measurements, take the compressed air pressure, and I'm talking pneumatic machines. There are others too, but if measuring a rock drill, for example, it is critical because the higher the compressed air pressure, obviously the higher the noise level. And you guys will say, can vouch for it, that rock drill operators doing his work is not an easy guy to get along with. You know, he wants to drill and he wants to finish his work and he wants to get out of the mine because that's his job. The thing is, now this young person comes here with a hypodermic needle and a pressure gauge and you want to stick a hole in the hose to measure the pressure. Yes, it's difficult, but that's the only way to do it. You have to take, when you do the measurements of the noise, you need the pressure because that will tell you whether it is a contributing factor to the higher noise level. Confined spaces, date, and the reference number. The equipment information is the supply, and Anton will allude to that. He will tell you what we're trying to put together, and he will explain it better, but I'm just mentioning it. It is the supply of the equipment, the type of equipment, the serial number, the activities, or the process measured. For example, drilling a hole, a shot hole, type, name, and description of the muffler. I think it's important. We often find that practitioners in the field measure the noise level and they leave. It is important to know that when you get to a particular piece of equipment, whether it's a compressor, whether it's a compressed air drill, whether it is a fan, that you understand what the silencer looks like. For example, those of you who do drop raising, you will not necessarily identify the muffler on an S36 drill machine just by looking at it. And that piece of equipment also has a controller on the one side. So you need to go and have a look whether the piece of equipment has a muffler. If you look at a mechanical loader that is used in the hard rock mines for development ends, it has a top and bottom motor. The top motor has a muffler and the bottom motor should have a muffler. Otherwise, it's not muffled. So for us who take the measurements underground, it is important that we understand the mufflers that are fitted to the various pieces of equipment that we measure. Because otherwise, we cannot give that information across accurately. Oops, I left my... So, on the back of what I just said now, so I'm back to my machine, the biggest contributor to noise in the industry at this stage. And we've got some examples in front here, similar to what you see there. But those are typically the mufflers that we see in the rock drills. You have, and I don't want to mention any names, but you've got this particular muffler that has a flat surface. It has a hole in the cylinder and gauze covering it. And this is what it looks like. So that is new, and that's what it looks like when it's repaired. And then you have a different type that has a slightly more angled cover. The holes look different, and these two are in front here, and this is what it looks like repaired. Now, looking at this, you can see these holes there are slightly bigger than the holes on that muffler. It depends on supplier, and it depends on what your company has accepted. Looking at the noise level, looking at these, if you see these things in this format, you will most probably take the noise level, measure it, go out, and that would be your noise level. Unless you pick up a very high level and you want to investigate. But what often happens, because the rock drill operators, there's a saying that from the rock drill operators, "Inakona duma, inakona jopa." It needs to make a noise. The guys grew up in that fashion. So it's important for us. A rock drill operator might take a marlin spike and enter that marlin spike through that hole and damage that gauze. You will not see it from the outside. You have to shine your light into that muffler. And now I already see some people saying, by golly, 3 measurements, switch off all the equipment, look at the mufflers, is this a full-time job? When you get good at it, it's not a full-time job. Okay, so they damage that gauze there. If that gauze is damaged, that noise level is going to increase. That's the bottom line. Some are much more visible, but the majority of the damage, and one of the senior engineers from Impala is here, without you seeing it from the outside, that gauze is damaged on the inside, and that is the reason for your high noise level. Now, what should happen now? That piece of equipment should be withdrawn from the workplace, sent to the rock drill shop to be fixed, and another piece of equipment issued to them. Otherwise, your noise levels are going to be high, and you're not going to beat the milestones. Sometimes, the damage is far more visible. And also some of the discussions that we've had in industry, very few people knew that this is what happens to the rock drills underground. You measure a noise level because the machine is facing the drill hole, and you're standing at the back here on the side. You're measuring here, and if you don't go and look into this portion here, you cannot see the damage on that rock drill. So I'm not referring to rock drills only. People take shortcuts. If the loader is perceived not to be operating according to it as fast enough, they'll take the muffler out. You need to look for those things when you do the measurements. So coming to the new equipment, the Mine Health and Safety Act imposes a duty of care responsibility on manufacturers of machines and equipment, Section 21 of the Mine Health and Safety Act. Accordingly, it's incumbent upon manufacturers to assess the potential risks imposed on the users of their products to quantify the noise emissions. That's the duty of the suppliers. It then follows that original equipment manufacturers must ensure compliance with the Mine Health and Safety Council milestones. So if somebody supplies a piece of equipment to you that is noisy, it's their responsibility to ensure that it meets the milestone. The moment you have bought that piece of equipment, it's yours. You're going to muffle it. And that's part of this process that the IBM QI is trying to achieve. We say in the document, and that's the guideline going forward, they must have, because often you find a pamphlet, and in this pamphlet is a noise level, and guess what that noise level is? 85 decibels. You have to take that piece of equipment at 85 decibels, you purchase it, and later on you cannot understand why you can't meet the milestones. So we say that noise measurement must be done by an independent, reputable third party, and a certificate must be issued. So when they come to your new equipment committee or whatever committee you have to control this, they must submit a third-party measurement certificate of a noise level of that piece of equipment. Then you can make an informed decision whether you want to take that piece of equipment underground. And then, when they change, and that often happens, when they change the design, because sometimes a particular piece of equipment or muffler is no longer available and they source another one from, let's say, China or one of those places, then they come and they change that, but they do not give you a new certificate. They should give you a new certificate because they changed the design of the equipment. So they must again then supply certification. The rule of thumb is, if you are in that committee and you are asked whether a piece of equipment with a 97 decibel noise level on a certificate is fit for your underground working place, the rule of thumb is to double that noise level, to make it 100 decibels, to say, when you give advice to your manager whether this piece of equipment should be used underground, you can make an informed decision by saying, the rule of thumb is that I add 3 decibels to that reading, and that's what that piece of equipment will be underground. So if you have rock drills where the guys say, yes, we're at 106 decibels, like Mornay said earlier, 99% of these measurements are free field. In fact, 100% of these measurements are free field measurements. So at a 96, you must add 3 decibels, or 106, you must add 3 decibels, so you end up at 109 decibels, which is higher than your milestone. And that's how this process is aimed at informing you on how to address these issues. Let's rather prevent the equipment from and put more pressure on the suppliers to fix it rather than us, the problem becoming yours. And that is my story. So I don't know if there are any further questions regarding the new equipment and the methodology used, the doubling of the noise level. Yes, sir.
You were saying the rock drill operators at times damage the machines and so on. So I'm just wondering as to what do we do about that behavior?
Okay. Maybe, it's fine, Dickie, I'll speak. Can you hear me? I've got quite a loud. Kobus, can you hear me? Okay. Yes, it's quite a challenge. There are real reasons why rock drill operators damage machines. On the shallower mines, those of you who operate in shallower mines, there are many reasons, but often, depending on your compressed air pressure, whether there's moisture, let's call it moisture in the compressed air, you may find, and obviously the contributing there is the design of the muffler, you may find that it freezes up. If it freezes up, the machine will no longer run. The operator wants to continue and finish his job, so what he does is he sticks a hole in it. So you have to engineer out some of those issues. Make sure that you've got enough water traps, that the water traps are serviced at regular intervals or cleaned out at least. And so that you need to do. There's also the other part of the coin where we almost covered all the aspects and you still find people damaging it. We at Impala, and if I may use that as an example, went through a particularly difficult process in 2009 when we muffled all the equipment that we had on our mine, specifically the rock drills. The rock drill operators were drilling a hole at a certain interval, so the machine was operating, it was making a noise, it was working well. You muffle it, you do impact on the penetration rate of that machine. It is the reality, it's how life works, or how this is designed. The aim is, the way to address this is to engage with those rock drill operators. We spent almost 2 years in meeting after meeting after meeting, trying to convince the rock drill operators that we have no choice. We want to give them the best performing piece of equipment, but because of the constraints, the design of the piece of equipment, and the milestones that are, and getting to zero harm, we have to muffle, and therefore we did lose some of the penetration rate of that piece of equipment. But it was, the answer to your question is, first of all, address that, what you can address, the engineering controls, and then engage with your rock drill operators to say, We have now done everything possible. It's still going to be slower, but we need to accept because we are all moving forward. I think everybody in this room, if a supplier will come up with a pneumatic, because our mines are designed with pneumatic equipment in mind, and therefore the reticulation systems are compressed air. If somebody comes up with a rock drill that can drill at the rate that we wanted to drill at less than 100 decibels, I guess that guy will make millions of rands. Will make lots of money because everybody will buy it. We have to, at this stage, manage the process because there's no way out of this. Muffling will affect the machine. You can go and perhaps spend time with the suppliers to look at various ways of muffling, but this is basically what I showed you here and what is on that table is typically what is available currently in the market as far as pneumatic machines are concerned. There are others too, such as, and it's a brand name that I mentioned, but it's known at that name is a Premfit machine. It is a very fast machine. It works very well, but obviously the noise levels are higher. Stan, does it answer your question?
James, just to put it in perspective, we're talking about time, but we're not talking about hours. Just from your point of view, is it a normal rock drill and a silenced one? Are we talking about seconds?
No, we're talking most probably minutes or so, Vaughan. 2.5 minutes. Thank you. 2.5 minutes difference in finishing a standard shot hole. Okay, which if you, depends on the number of holes, it depends on how many rock drill operators, it can have an impact.
Thanks.
Any more questions? JJ?
James, and I would like to reflect on the current initiatives, and I mean, making as the judge, jury, and executioner again becomes very difficult. I mean, with the declining internal department, it's very difficult to get those number of measurements or verifications underground. I mean, I'm going back to a rock drill shop. I mean, at least we're seeing 200 rock drills coming through a workshop, through a rock drill shop. And I mean, when you get 200 rock drills coming through a workshop, surely we can put a check and balance in there to say, well, maybe there's a reference value on a second attenuated rock drill. That reference value compares favorably for underground, and then there should be a reference measurement there to say, okay, if it exceeds this, then one should tag it out. And one can also then do the inspections for these damages on these drills. So hopefully we can put something through the chamber rather as opposed to us going underground and do these spot measurements and methodology of measurement. So that's just an idea out there.
Okay. Sorry, Vaughan?
Sorry, James, I just want to make more or less the same comment, is that part of this initiative is maintain. And I think exactly that process, when you buy new equipment, it comes out with a specification. But I think when you have your third-party people maintaining the equipment, or you do it in-house, you need to have those checks and balances. You need to test that equipment before it goes back underground into the environment to make sure that it complies at least before it goes back underground. It doesn't help you send equipment back underground that does not. And it goes for all the equipment that comes out to surface for refurbishment or repair.
We had an interesting meeting, the one that I alluded to earlier is when we visited specifically an area there on our mine where we have such a system in place. Yeah. Any more questions on this issue? Kobus, did you want to ask something? Okay. Mornay, do you want to add anything? All right. Can I now take this off? Thank you.
Can we have a round of applause? James, thank you very much.